What is up, everyone? This is John Paul Raj bringing you yet another video on how we can make the learning of math fun. In today's video, we're going to talk about the graphing app on the TI Nspire CX-II. Now, this is for beginners only. So if you're an advanced user of the TI Nspire CX-II, then this video is not for you. All right, let's go. Whenever anyone buys a graphing calculator, the first thing that they want to do is they want to look at the graphing option. They want to learn everything about the graphing option. But we've not gone into the graphing app directly. We've gone and seen settings. We saw problems in pages. We saw the calculator app. And today, only today, we are ready to take a look at the graphing app. So I'm going to start by adding a graphing page that says graph page. The first thing you see when you insert a graph page is this F1x. Automatically by default, the calculator prompts the entry for a function in a function mode. F of x refers to a function. For those of you who have not done functions in school as yet, f of x represents the y value of an equation. Let's just call it an equation right now, but it's a special kind of an equation. And if you want to know more about functions, you can take a look at my videos. I've made a series of videos on functions. All functions are also equations, but not all equations are functions. Therefore, I said that, this is just the y value of that equation. But since this is a beginner level video, I'm not going to go through this entry first. I'm going to first show you how to enter the graph of any equation in relation mode. So you might also be wondering, how come I have this grid and you don't have, because the default settings is just like a plain background? Well, you can go to the menu, and under menu settings, the first thing I always like to show is the settings, where all the settings are. So these settings are specific to the graph page. And if you click that, it says that's for the graph and the geometry settings. You can see there are settings for the display digits. You can change that one also. We saw a little bit of this on my very first video getting started with the TI Nspire CX-II. And here under grid, you can see I've chosen lined grid. You can also, I think the factory default settings are no grid, which is why your screen probably looks something like this. I like that grid, so if you like this view, you might just want to go to settings and change that to lined grid. I'm going to say okay. All right. The first thing that I always teach my students is how to change the window settings. I think by default, the X settings go from -10 to 10 and -6 to 6 on the Y. But I tell the students to try and look at what's given on the question paper. This is an IGCSE question paper. As you can see, the window settings, the x min is -4, the x max is 4, and the y goes from -10 to 10. So the first thing I tell my students is first try and figure out how do we change these settings according to what's required on the question paper. You may also have a case where the settings are something like this. The x values range from 0 to 360, and the y values go from -3 to 3. Therefore, it is important to first understand, how do I make these changes on my calculator? So let me switch to the calculator. And in order to make those window settings, or to make changes to those window settings, I go on menu. Menu is my lighthouse. And under menu, I've got so many options, actions, view, graph entry, edit. We'll come to that. And this thing called window/zoom, number 1, which says window settings. Here's where I can make the changes according to what's given in the question paper. I'll make it according to that first question that I saw, which had -4 on the as the minimum x value. So -4. And I can hit tab just to go to the next entry. X max was +4. The scale, X scale, you can either choose auto or you can give some specific value, the increments, okay, the divisions. I'm going to say 1, okay? Auto means the calculator will automatically find something that is, but I like it to be a little good looking. It came 1. I want to say, actually it came 2. I want to say 1. Y minimum, according to the question, was -10. So we're going to make that -10. Y max was 10. So hitting tab to the next field. And again, Y scale says auto. I'm going to change that to 1. I like 1. Okay. We'll see what it looks like, and then we can make a change. So that's where I go and make the window settings. So I hit OK, and automatically the display is just as what is required on the question paper. Now, the next thing is how to enter the equation of a line. Let's just start with an equation of a line. So I go to menu, my lighthouse, graph entry edit. Can you see that? That's what I want you to do. Okay. So when I go to graph entry edit, under relation, okay, relation, I choose relation, and it will give me the entry box for a relation. I can enter any equation. 2x plus 3y is equal to 7. And when I hit enter, it'll graph the equation of that straight line, 2x plus 3y equal to 7. It also shows the equation of that line. Okay. In the same way, I can go back to menu again and go back to graph entry edit, and again say relation, and I say another equation this time. So 3x minus 7y this time is equal to 11. Let's make it 11. Let's hope that they are intersecting. Oh yeah, they are intersecting. And so I've got these two equations, and they're intersecting somewhere else. And this is good. We can learn the other feature. So it's intersecting somewhere here. But what we saw right now is how to enter the equation of a line. I'm going to do that again by inserting a new problem. Okay, so we are going to go to doc and insert a new problem. Okay, and for those of you who have not seen that video of mine, problems and pages, go take a look at that. I'm going to insert a graph page this time, and as you can see, this is 2.1 and this is 1.1. Problem 1, page 1, a graph page. Problem 2, page 1, another graph page. And the reason I did that is to show you that automatically by default, you'll see that the entry line is in terms of f of x, f1x it says, f1, f2, f3, but in terms of f of x, the function. And you might be confused, like I said, if you don't know what to do, if you've not done functions. All you need to do is that hit escape and that entry line goes away. You can go to menu and go down to number 3, which says graph entry edit, and make your way to number 2, which says relation. And there you can enter the equation of a line, the circle. Let's enter a circle, why not? Okay, so x square plus y square is equal to, let's say, 3 or 9. Do I have 9? Yeah, it should be. Yeah, there you go. So that's the equation of a circle, and the graph of that circle is also displayed. So basically what I wanted to show is that by default, the calculator will prompt you to enter the equation in function form. That means making y the subject of the formula. And if you have not yet studied, and if you don't know how to do that, you might as well go and make the entry as a relation. Okay. The next thing that I want to talk about is how do we zoom to a particular area of interest. That's where my point of intersection is. And say I wanted to find the coordinates of the point of intersection. We go on menu, our lighthouse, and we choose Windows Zoom, the same option where we went for number 1 for Windows settings. There are several zoom options. Zoom box is something, let me show you. If you just choose zoom box, you can actually, create a box around the area of interest that you have. As you can see that, it's just click and drag, and there you go. You can see that intersection point a little better because we just, let me just see if you can zoom again. There you go. Okay. The black line corresponds to the x-axis. The red and the blue line correspond to the two equations that we've plotted. And that is the point of intersection. Well, we'll talk about the point of intersection in a minute, but I just want to go back and show you the zoom options. So menu, Windows/zoom, and there are several options I showed you about zoom box. You can try and play around with zoom in, zoom out. I find whenever you use like trig functions and you're graphing trig functions, zoom trig is helpful. Zoom data is very helpful when you're doing a scatter plot. It'll really help. Zoom fit is also interesting, but there's also something called zoom decimal. Try it out, whatever comes out. Basically, you need to make the graph friendly for you to be able to use whatever you're trying to find out, whether you're trying to find the point of intersection, whether you're trying to find the coordinates of the maxima, minima, whatever the question requires, okay? So I just showed you how to zoom into a particular feature. The next thing we're going to take a look at is how to find the coordinates of the point of intersection. And in order to do that, we go to menu, our lighthouse, and there, number 6 is analyze graph. Under analyze graph, we've got several options. 0 refers to the x-intercept, minimum, maximum. When the graph has a local minima, local maxima, you can use those options to find the coordinates of the minima and maxima. But now we're going to take a look at option 4, which is to find the point of intersection of those two lines. When I click intersection, it gives me that dotted line. That's not a vertical asymptote, by the way. As you see on the left-hand corner of the screen, it says lower bound. Basically, what it is doing is the graph is asking you a question. Let me explain this on my iPad, okay? So what it is doing is, let's say you have this graph. Can you see this thing? All right, you've got this two lines intersecting. Basically, what it's saying is that between what interval is this point of intersection? Now, two lines will only intersect in 1 point, maximum 1 point. But what if you had a graph which, something like that, and there's another graph like something like that? You've got more than 1 point of intersection. So basically what the calculator is asking, or in other words, the algorithm used to program this feature on how to find the point of intersection, you'll find the same thing happening when you're looking for the maxima or the minima. The algorithm used is, it's asking, well, you want the point of intersection, but state the interval. So within this interval, this is called your lower bound. and this is called the upper bound. That's what the calculator is asking in that interval, or it's asking you which interval are we looking at. Are we looking at this interval? That would mean this is the point of intersection. And if you're looking at this interval, which means corresponding to these values of x, this would be the point of intersection you're looking at. So going back to the calculator, like I said, that's only one point of intersection. So the lower bound means somewhere to the left of that point of intersection. And then you can click there. And when you just move the point around, I've not even clicked to the right, it already shows me the coordinates of the point of intersection. Now to make things pretty, you might want to just pick it up and keep it somewhere where you can read, and then you can make a note of the coordinates of the point of intersection if that is what the question is. So the coordinates of the point of intersection of these two lines that I just made up is 3.57 comma negative 0.043. That's up to 3SF because that was the settings. You know where to find that, right? That's on menu, settings, and this float 3. These settings are only pertaining to the graphs page, not the universal settings of the document. Okay, so here if I go and make the setting something like, let's say 1 decimal place, fix one of 1 decimal place, I hit OK and automatically it gets updated. All right, now let's take a look at that sample question from the IGCSE paper. I'm going to just clean it up before we do that. This question is from an IGCSE paper. I just had to quickly clean up what I had scribbled while I was talking to you guys. But let's take a look at how we can solve this particular question. The first thing, like I said, first let's just make the changes to the Windows settings. Okay, this is 0 to 360. It's in degrees. As you can see, the question is about two graphs here. F of x is given. And again, if you've not done functions, for this video, just assume that these are talking about the y values, okay? Y values of that particular equation. Like I said, a function is also an equation. And if you've not yet done functions at school, you may want to go and take a look at some of the videos that I've made on functions. But for now, let's just think of the f and g representing the y values of each of these equations. Okay? So we are going to go back to our calculator page and let's insert a new problem by going to doc, insert a new problem. And this is going to be a graph page because we're talking about the graph app today. And as you saw, that automatically by default it gives me the entry as a function f1 of x, but this time we're going to use it. So I'm going to enter fx as f1 of x, the first function. So this is 2 sine x plus cos x, as it says, plus cos x, and when I hit enter, it gives me some graph, but you can see, and sometimes students just jump and say but it doesn't look like a sine graph. Well, that's because our Windows settings was the first thing that we should have done, which I told you the first thing you should do is change the Windows settings, which I did not do right now. But this is a good thing to learn by making mistakes. I made a mistake. So let's go and change that Windows settings right away. So menu, Windows/Zoom, Windows settings, and the X values went from 0 to 360. I'm going to make that 0, X minimum. Tab to go to the next entry, 360 for the max value of X. And I'm going to just make the scale to, let's say, 30 degrees. And Y min and Y max, it went from -3. Hit tab to go to the next entry to 3, I believe. And the scale refers to the divisions by which it will be displayed on your calculator. So there you go. That's the graph of 2 sine x plus cos x, 0 to 360 degrees. That should be 360 degrees, and -3 to +3. And you need to copy down the graph as it is given, okay? As it is given, you just have to copy it down. But here's the thing. When you're copying down the graph, wherever the question says sketch, I'll just show you the question again. This was a question, and it said, can you see this word? Sketch. Sketch. Now, even if you're an IB student who's watching this video, when you see the word sketch, even in the IB papers, this word is used, sketch the graph. That means on a paper where the calculator is allowed, what the examiner is looking for is that you can draw a freehand sketch by looking at the calculator, but you need to indicate the key features. Key features. You need to indicate the key features of the graph. That means, you need to indicate where the graph has a y-intercept or an x-intercept. Where does it have a max or a min? If it does have, then you need to indicate what you see on the graph. A freehand sketch will do, but make sure that you indicate all those features. And that is what is taken into account when you answer a question where it says sketch, okay? So without further ado, let's go to the calculator page and find out how to locate the maxima, minima, intercepts, and so on and so forth, okay? Our lighthouse is the menu. We go to menu, analyze graph, and I already showed you this menu that pops up. 0 refers to the intercept, the x-intercept, and I click that and you see that dotted line again. It's basically asking you, it's prompting you to define the interval around which you're looking for the intercept. So I'm going to say I want this x-intercept and, to the left of the intercept, and then move the cursor to the right, and I get the intercept at 153. Okay, 153.4 degrees. That's the x-intercept for this function, to sine x plus cos x. You want to find the second intercept or the second 0, you go back to menu, analyze graph, 0, and again you mark the interval around which you're looking for the x-intercept. And the reason I'm showing this is because the question which asks for sketch, you need to show all these features of the graph, okay? Max and min, let's do the same thing. Go to analyze graph, minimum value is here, so we go and, around that interval, the coordinates of the maximum and the minimum can be found just like that. And then when we go to menu again, analyze graph, take a look at the maximum value in that interval. 63.4 is the value of x, and 2.2 is the maximum value at that value of x. So when you indicate all the key features of the graph on your sketch in the answer booklet, you will get the full credit. Now the second graph that we need to enter is gx is equal to 2 minus log x. Let's do that right away. In order to bring the function entry line again, I'm just going to hit tab. That's a shortcut. Pro tip, shortcut is tab, and I get the function entry line again. This time it says F2, and we're going to call F2 as G. It says 2 minus log x, so that's 2 minus log x. Log is up here, that's on the left hand side of 1, but with the control key, when I press that, I'll get log. And when it says log, we are referring to the common logarithm, log of x. And I just hit enter, and there is the graph of log of x to the base 10, which is the common logarithm. I'm just going to move this label away. And when you're going to make this sketch on your answer booklet, make sure you indicate the key features. So let's go and do that quickly. The x-intercept, if you want to indicate analyze graph, the 0 for the red graph. We're looking at the red graph. Look, now the calculator is asking which graph, because it's asking, hey, there are 2 graphs. So we say we want this graph, that's the log graph. And then it says, okay, the lower bound, the upper bound, and there, that is the x-intercept for the graph G. Let's get back to the question now. And part C says, solve the equation. You see this? I want you to pay attention to this one. Solve the equation. This is F and this is G. All right. Now pay attention to what I'm going to do. All right. I'm going to call this graph 1. And I'm going to call this graph 2. This was F and this is G in our question. Okay, graph 1, graph 2. And the question says, where are the 2 graphs equal? And anyone will say, well, whenever 2 graphs, no matter what the shape is, they are equal means you're looking for the point of intersection. And that is what we had seen earlier. So in order to solve this equation, 2 sin x plus cos x is equal to 2 minus log x, all that we need to do is find the point of intersection using that feature on our graphing app. Let's do it. So as you can see, these 2 graphs are intersecting in 3 points. This is 1 point, this is another point, and this is the 3rd point. Okay. Now I'm going to first show the technique that I'd shown you earlier, which was menu, analyze graph, intersection. And when we click intersection, it will give me that prompt for lower bound or upper bound. So if I do that, it gives me the first point of intersection. All right. I'll have to do the same thing 3 times to get the coordinates of the 3 points of intersection. There is another way to find all the 3 points of intersection in one go. Watch. So first I'm going to just hit undo. Okay. Command Z or Control Z will undo the previous operation. What we're going to do is that we're going to go to menu, geometry this time. And under geometry, points and lines. And number 4, which says intersection points. We choose that. There's a prompt on the left-hand corner which kind of gives the hint. It says click on the first graph, then click on the second graph. So we do that. We click on the first graph, and then even before we've come to the second graph, we've not even clicked there, automatically, can you see it's almost grayed out? So you click the second graph and you can see all the 3 points of intersection just like that. I'm going to just hit Command Z to undo to show you again how we can find the 3 points of intersection in one go. Ready? Menu, geometry, points and lines, intersection points, and you will see this hint which will prompt you saying click on the first graph and then click on the second graph. So we click on the first graph, and then when you click on the second graph, you will get all the 3 points of intersection just in one go. These are the 3 solutions. By the way, this is up to 1 decimal place. I just showed that to tell you where the settings are. It's going to change that because in the IGCSE exams, you will need to report the answer to 3SF. So we're going to change that. Now these are the 3 solutions in 3SF, 6.18, 159, and 320 for the equation 2 sin x plus cos x is equal to 2 minus log of x using the graphing app. Now let's take a look at a similar question from the IB paper. This is the question. Sketch the graphs, as I said, sketch. Hope you know what that means, okay? Showing all the key features. Sketch the graphs of y equals x over 2 and y equals the absolute value of x minus 2. They have given you the grid. So the first thing you got to do is that making sure that the window settings are right. But take a look at part B. It says solve. Solve the equation. And again, we're going to use the same strategy, graphical method, which means we're going to say the left-hand side is one graph. So let's call it graph 1. Graph 1. And the second one is graph 2. All right. And it says where the 2 graphs are equal is where the 2 graphs will meet, the points of intersection. So let's do this on our TI Nspire CX-II graphing app. Here we go. Let's insert a new problem and a graph page because you're talking with the graphing app today. It says f1 of x. And I think sometimes because of this, I'm tempted to write the function directly, but a good habit is to first change the window settings, the x min, x max, according to what's required on the question paper. So the x min, x max was -4 to 8. So I'm going to go to menu, window zoom will give us the window settings. And here I'll make that from -4. Hit tab to go to the next entry, 8. Auto is not required. We will make this 2, I think, because, well, that's the way it's there on the question paper. Y min goes from -4, the minimum value for y, up until 6. And I think here the divisions are 1. So the scale, we can bring it to 1. And here we can say, okay, and that's the window settings given in the question paper, okay? Now we can enter the functions. So you can either use the shortcut tab, or if you don't know where that is, you can go on menu, graph entry, edit, and function is what we want to enter. So x by 2 plus 1. So control division will give me the template for the fraction. X over 2, hit the arrow, plus 1. And if you want, you can move this label away. And now if you want, the shortcut is tab. That brings the graph entry line again. And I will say I want to enter absolute value of x minus 2. The template key is here, the right hand side of 9. When I hit that, that last thing on the corner is for the absolute value function. X minus 2 I enter, and I hit enter now, and that should be the graph of y equals x minus 2. The second part of the question, as you saw, asked us to solve these equations, which means graphically the point of intersection. And now we're going to use the geometry app, okay? That means finding the point of intersection in one go. So we go to menu, geometry, points and lines, and hit intersection points. And as the hint says, click on the first graph, then click on the second graph. So click on the first graph, click on the second graph. And as you do that, you will get the solution to the equation absolute value of x minus 2 is equal to x over 2 plus 1 using the graphical method is x equals 6 and x is equal to 0.667. On the next video, we're going to talk about the table, the slider, and other cool features of the graphing app. If you have any questions about the graphing app, the calculator app, or anything in general about the TI Nspire CX-II, please do mention on the comments below. And do not forget to subscribe to my channel. See you in the next video.